Good evening. APIs. Most of the content from my talk tonight has come from a project that I've been working on for the past couple years called Medaction. It's basically an iOS application that talks to a Rails-based API, and it's used in a hospital environment. And so a lot of this content comes from lessons I've learned on that project. Now, when you're talking about APIs, APIs are everywhere, right? Any two systems that are going to interact are probably going to use some sort of API, whether that's like a remote procedure call or a traditional HTTP-based API. So what I'm talking about tonight is the HTTP-based API that's probably going to use XML or some other encoding to send data back and forth. So it's kind of specific to that, but some of the ideas can be used in other areas too. What's cool about Rails is that Rails provides a pretty established path for building an API. Rails has been around for a while now, and a lot of people have built APIs with Rails, and so the road is well traveled. So if you're going to be building an API, Rails might be a good choice, even if you're just prototyping, because lots of folks have probably run into the same problems that you'll run into, and they probably already have some solutions out there. The thing about APIs is it gives us an easy way to interoperate with systems while maintaining isolation, right? It's like another abstraction layer. So what's been big these days is service-oriented architecture, right? So we want to build our systems in isolation from each other. But then when they talk to each other, you need some predefined set of instructions or some patterns for talking with each other. So we expose part of our system through this API and allow other people to talk to that. And then they don't have to know about the full complexity of our system, right? In my mind, the most important thing to take into account when building an API is figuring out who's going to be consuming your API. Is it going to be another website? Is it going to be some JavaScript running in the client browser? Is it going to be an iOS device? Is it going to be a developer using the command line, calling your API with curl? Because a lot of the decisions you make about how to structure your API will depend on who's consuming it. So generally, when you're building an API in Rails, you'll use the whole controller model. So we'll create our API controller, which subclasses from application controller, and then we'll just create our regular action just like we would for a normal web view. In this case, we're pulling back some cases from the database and rendering those out as XML. And you'll notice the render XML command, which is going to make sure our cases render as XML instead of rendering as like an ERB template, like a traditional web view would do. Once we have our controller, we need to set up a route for the controller. And the scope command up there is going to scope all of our paths with an API prefix. So you'll see an example of the URL below where there's an API prefix there before the cases.xml. So by scoping our routes, we ensure that all of our API calls are segmented off and can't accidentally be triggered by our web views. Because traditionally, for smaller Rails apps, you're going to have your web views and your API actions living together in the same application. And then we'll set our controller to API. As API is, if you're going to use any named routes, that'll prefix your named routes with API underscore. And then for constraints, we set our format to XML. And down here in our actual route, where we're matching on cases.format, it's just going to substitute XML in there. So it'll end up being cases.xml. And by using a format, it makes it nice because if we ever switch from XML to JSON or from JSON to property lists, which we'll go into a little later, all we have to do is change it in one place. So we map to our action, get cases, and via get is ensuring that we can only access this route using an HTTP GET request. And so all of that maps to the URL at the bottom. And once we have our route set up, we might want to test it to make sure everything's kind of hooked up properly and working properly. The simplest way to do that is just fire up your browser and hit the URL. And you should see the XML appear in your browser window. If it doesn't, something's probably wrong. Another way to test is from the command line. You can just use a curl command with the .h, which sets the content type to application XML, and that ensures that the request being sent has the correct MIME type. And then you hit your URL, whatever that's going to be. If we're running locally, it's probably localhost 3000, and you should see the XML print out right in your command line there. And then a third way is from an automated test. And if you're not just prototyping something, then you'll probably want to go with an automated test. If you're writing an action that's going to be in your system for a while, you want to have some way of verifying that it works. And we all test, right? So why not have an automated way to do it? So this is an example of a Rails integration test that will test the action that we just wrote. You'll see it's just a get cases test class that inherits from integration test. And we're calling get on our URL that we wired up with routes. We're asserting that the response that was returned was okay. And then we're calling hash.fromXML, which is a nice little method that will take an XML string and convert it into a Ruby hash. And we pass in the response body, which is our XML, and then we assert that we're getting back 3 cases. And of course, this test is predicated on the assumption that we've created 3 cases in our database as some sort of setup or initializer before our test. And of course, you may want to expand this and do other things like actually verify that certain fields are included in the XML, certain fields on the case. But this is just like bare bones to get you started. So now we have a controller and a route that wires it up, and we have a test to verify everything's working. But we probably want to protect our API as well. Now, if you're writing a public API, this might not be applicable. You might just want to have it open to everyone by default, although it might be a good idea to consider some sort of cap on the number of requests that can come through at any specific point, because you don't want someone to kind of do a denial of service attack. But if it's going to be a private API, or you want to have a little bit more control over who's accessing it, then you'll need to set up authentication. And the simplest way to do that is just straight username and password authentication using HTTP auth. It's really easy to get started. The downside, though, is that you're going to be sending a username and password over for every API request. That might be acceptable in your system. It might not. You might want to go with something like a session token, which is a little more disposable. So the idea with a session token is you authenticate with a username and a password once, and you get back a session token, and then you use that token in future requests to your API. What's nice about that is you're not always sending a username and password, and you can set the token up so that it expires after a certain amount of time, which is a nice little security thing. And additionally, you can even set things up so that you as an admin can log in and see which tokens have been sent out and who's currently using your system, and you can say, hey, I want to kick that person out, or I just want to clear all the tokens, if you've had a breach of your system. It's a little more involved to set up token authentication, but it's generally what you're going to want to do. So this little bit of code will actually create a session token, and the example I'm showing here would be used as part of your API. So you'd have one API call off to the side that you authenticate against using a username and a password, and that returns your token. But you could also use this as a traditional web view. Just stick this in a web controller as an action and have users log in through their web browser and retrieve a token that way. And then they can use that token from curl on the command line or whatnot to access the other actions in the API. But basically, it's pulling back an email and a password. The email in this case is serving as the username. Get auth data is returning the HTTP auth credentials, and that's a pretty common thing. You can Google to see what that code looks like. And then we're authenticating using the email and the password, using our password authentication class, which is going to do a lookup in our database and make sure that that user really exists. We're returning the user object. If we don't get a user object back, then they're not authenticated, so we deny access. If we do get a user object back, we're creating a new session record in the database. We're rendering that back out as XML with an HTTP status of created. Otherwise, we return an error message and say, hey, this failed. Now, in our actual API controller, we'll want to protect certain actions, and this is how that would be done. One example. User login required is a method that can be added as a before filter, is probably the most common way to do it. And basically this ensures that no matter which format we're using, whether we're accessing as a web view or accessing as an API call with a MIME type of XML, that we're going to be able to log in either way. So if we're accessing from the web, it's going to, under the format.html up there, we're going to log in using the username and password. But if we're accessing over the API through XML, we're going to log in using our session token, which falls down into the login by session token method there, which is just doing a lookup on the session, find by token. And if we find a session, it's setting the current user to whichever user was associated with that session originally. It's pretty straightforward. And of course, in either case, if we weren't able to log in, then we just return access denied. And these are a couple of examples of what those could look like. If we're on a web view and access is denied, then we just set a flash error and redirect to a login URL. Whereas if we're accessing through our XML API, then we'll just render some text out with a HTTP status of unauthorized. So now we have our API, and we have authentication set up, so it's protected. And a few months go by. And somebody wants a change made to the API. Maybe a new version of the client software has come out, and they want some changes made. So what do? Well, we could go back to our original API controller and just make the changes and hope that everything works. But that's probably not going to be a good idea. The potential to break backwards compatibility with older versions of the client software is there. So a better thing to do is to consider versioning your API. And this will insulate you against these kinds of changes and ensure that your API remains backwards compatible. And as a side note, it also seems to help with organization of controllers and actions, at least for me. It's easier to get my head around what's going on in the app when there are separate directories for each version of the API. So here's an example of a couple of controllers that have been versioned. You'll see we took our original API controller and renamed it API v1 controller, and it still does what it did before. Our API v2 controller subclasses from our API v1 controller, so it inherits all the same actions and everything. But we're overriding our action and adding a modifier. Maybe we added a public field to cases, so now we want to filter where that public field is true. So our original clients can still call the version 1 controller, but our new clients can call into version 2 and get that new functionality. And what's nice is by subclassing the version 1 controller, we get all the actions that we've already defined, and we can just override where it's needed. And this is how the routes would work with a version controller. You'll see we added v1 to the scope. So now we're not only scoping for API, but we're also scoping for the actual version number. So we might have another URL that's v2, and eventually another URL that's v3. And all three URLs will call into separate actions with separate functionality. And that's really the only change. You'll see we renamed the controller to API v1, so we're referencing the correct one. And of course, you'd have to have another scoped block like this for v2. There are a couple of gems out there for doing this kind of versioning, RESTful route version and versionist. I haven't used either one because honestly doing it by hand has worked fine. But I imagine they offer some pretty nice things, so check them out if you have time. So a little bit about Medaction before we go into plists. Again, it was an HTTP-based API and the client code were on iOS devices, iPads and iPhones. And it's hospital software, so pretty universally hospitals have bad Wi-Fi and low bandwidth, and the connections would go in and out, and it was a mess. The Wi-Fi was not reliable at all. So that presented some latency issues. We also ran into trouble when we used XML initially because the serialization and deserialization was really slow. Initially we tried switching to JSON, and that improved performance by about 10%. But switching to binary plists improved performance by 20%, and also ended up being a lot easier to implement on the iOS side. So that was a big win. And something else we did to boost performance was combining multiple API calls into one. So we might have several API calls to pull back separate information about a patient. By condensing that into one call, since latency was so high, that got us a good performance boost at the expense of some complexity. So these are the various types of transport encodings you can use in your API. XML is pretty much the default. We've heard of JSON, plist, and binary plist we'll get into in a second. Proprietary, I'm just including because your company might cook up its own proprietary transport encoding that it wants to use, whether that's XML with a custom DTD or just some binary format. So XML, of course, is a common choice, built into Rails, easy to produce and consume, but the documents get very, very large, and a lot of times it's slow to parse because of all the start and end tags and whatnot. So JSON is a good option. It's becoming more popular. Also built into Rails, easy to produce and consume. The documents are more reasonably sized, making the parsing faster. What's cool about this too is if you're using a database like Postgres, it has built-in support for storing JSON. And if your JavaScript on the client side is consuming the API directly, then it doesn't have to do any translation of the data it's getting back. It can just pull the data right back and start using it immediately. So that's a big win. Property lists, or plists. So this is a common storage format on Mac and iOS devices. You've probably seen these files floating around with a .plist extension. They're usually used to store user and application settings. Originally, the plist format was not XML. It was just ASCII format. It actually looks kind of like JSON. But then they switched to XML with their own publicly defined DTD in OS X. And plists are faster to parse than plain XML. I think since they have their own custom DSL and a limited number of tags that can be in the document, that makes it faster and easier to parse. So if you're using any kind of Mac or iOS device, it's probably going to be a win because a lot of this stuff is already built in. Now, binary property lists were introduced in OS 10.2 to overcome the XML document size. It's just a compressed plist. If you open it up in TextMate, it just looks like binary junk. What's nice is it's much more compressed. It uses less bandwidth to transfer, and then there are tools built into OS X to convert to and from binary plists. What was great for mid-action was, since bandwidth was so limited, by switching to binary plists, we greatly improved the transfer speed.
What tools are built into OS X for plists?
These. plutil is the command line tool, and that lets you generate, manipulate plists to convert to and from binary from the command line. It's pretty straightforward to use. Xcode, of course, can open plists, manipulate plists. I mean, if you've done any iOS development, you already know that. TextMate actually has a way to convert binary plists to ASCII plists. There's an option in the menu to do that, but you can't convert the other way, at least not that I've been able to tell. And Sublime Text apparently has some support for converting to and from plists. I've never actually used it, so I couldn't say for sure. And then AppleScript also has ways to manipulate plists. So if you're doing any kind of automation, that could be handy. So these are all the tags that make up a property list. There aren't very many, which is kind of nice. On the left, you'll see the foundation class that they represent. In the middle is the actual tag, and on the right is a description of the content. So you'll have a string, which is just a UTF-encoded string. We have numbers, reals and integers, booleans represented by true and false, dates in ISO 8601 format, base 64 encoded data. Arrays can contain any number of other child tags. And then dict, which stands for dictionary, which is like the plist equivalent of a hash. So on the left, you'll see an example of a simple plist, and on the right is the Ruby equivalent. So you'll see it's essentially just a hash, a dictionary with a key of patient, and the value is another dictionary, which has key of last name, first name, which are strings, and then patient ID, which is an integer. So it's very easy to write these by hand if you have to. It's very easy to understand what's going on in them. If you're modeling a very, very complex object, it can get a little hairy, but generally it's pretty straightforward to read. So that being said, how do you get plist support in Rails? Because it's not built in by default like XML and JSON. And there are really just 4 steps. There are a couple of gems out there to handle converting to and from plists. CF property list gem actually supports binary plists, so I'd recommend using that. We'll set up a custom param parser, which handles the incoming plist data and converts it into Ruby hashes. The plistifier initializer handles outgoing, so it'll convert your active record objects into plist data. And then finally, we have to add a converter method on our active record models to actually turn them into hashes that can be converted into plists. So again, CF property list is the gem I'd recommend and the one I've been using to read, write, and manipulate plists. It's nice because it handles binary plists as well. By the way, my slides will be posted on the Raleigh.rb.com website, so don't feel like you have to write down all the links or anything. So this is the param parser to handle incoming data. And this is just a standard Rails 3 param parser that we'll set up with a MIME type of plist. And we give it a proc that's going to actually process the incoming data. And we use CF property list here to create a new list with that incoming data, which is just the plist data that I showed earlier, the tags. And then we call this native types method on CF property list, which takes the list and converts it into a Ruby hash. And then this underscore keys business there is to convert the plist keys from camel case to underscore, since in the Ruby world we like underscores. But for plists, camel case is kind of the default. And of course, if for some reason any of this failed and we didn't get a hash back, then we just return an empty hash by default, since we don't want to have to deal with any nil objects floating around in the system. So that handles stuff that's coming into our controllers. Now to go back out, we use this plistifier initializer. And the first URL at the bottom there is the Rails 2 version that I took and adapted for Rails 3, which is the second link. But basically, it's just a big chunk of code that was too big to put up here. But you throw it in an initializer under config initializers in your Rails project. And it defines a method called render to plist on action controller base, which basically lets you render with a symbol plist instead of a symbol XML or JSON. And it also lets you configure a converter method for your active record models, which is 2hash by default. You can rename it to something else if you really want to. There's also an option in this initializer to convert unknown type to string. And what that does is if you're attempting to convert a Ruby hash that has some sort of custom class in it that can't easily be converted to a plist type, it'll just try to convert that straight to a string and include that in the plist.
When you mentioned that it was 20% faster to use binary plist, was that for Rails to parse that and serve it, or was that just the bandwidth portion, or was that actually just...
That was like total time, yeah. Yep, round trip. And finally, here's an example of what your toHash method on your active record model might look like. And pretty straightforward there. The keys, of course, are camel case, since that's what plist is recommending. I suppose the plistifier initializer could be enhanced to convert underscored keys to camel case keys, but I felt like that wasn't really necessary since I'm only ever using these toHash methods for plists anyway. It would just be an extra level of indirection. And so once those four things are in place, instead of calling render XML, we can call render plist from our API controller. And if you bring that up in a browser, you'll see a nice little plist come back. And we can change our routes. The format switches from XML to plist. And our URL ends with .plist. Our integration test, we're calling get on API cases.plist. And instead of calling that nice hash.from XML method, we have to kind of write our own, which is the parse plist method down here, which does a similar thing to our param parser, calling into CF property list to convert that plist into a native Ruby hash. One other thing about this. CF property list has a toggle to switch between XML and, the plain XML plists and binary format plists. So that's something to keep in mind, like if you're writing tests and you want to assert against the plist that's getting returned, you probably want to toggle CF property list to be returning XML. Because if it's returning binary in your integration test, there's not going to be a lot of assertions you can make against that, unless you want to take the time in your test to convert that binary back out again, if that makes sense. So just something to be aware of. But in conclusion, APIs in Rails are easy. Think about who's consuming your API, and certainly I would recommend if the consumer of your API is an iOS device, consider at least giving plist a try. I talked with one of the iOS developers on Medaction today, and he said, all the support he needed for consuming and producing plists on the iOS side was already there. He didn't have to add anything extra. So for him, it was a really simple change when we moved to plists. And of course, with the 20% speed increase, it was well worth it. Here are some of the gems I mentioned. The second one up there, I hadn't mentioned yet, but it's CF property list Rails, and what that does is it kind of takes the 4 steps that I outlined and kind of packages them up into a gem. I haven't actually used it. You might want to take a look at it if you're thinking of doing something and you don't want to do all that coding by hand. plist, the third option down, is another gem that handles consuming and producing plists, but of course, as far as I know, last time I looked at it, it didn't handle binary. And these are some additional articles if you're interested in learning more about versioning or testing APIs. I found these to be really, really helpful, so I highly recommend reading them if you're going to be working on this kind of stuff. So, any questions? Yeah.
So on